Hello, everyone. My name is Nicholas Hovde, and I am a graduate student at the University of Dallas pursuing my Master of Science degree in Business Analytics. I anticipate graduating this upcoming May of 2021. For my practicum presentation, I want to focus on identifying hate speech in Internet memes. As a precursor to my presentation, I want to provide a framework and outline for the steps I will take. I will first answer questions about multimodal content and identifying what a hateful meme is. Then I will provide my business questions and analytics plan. Next, I will provide an overview of the Facebook Hateful Memes dataset and challenge. Next, I will show the discrepancy in accuracy between human intelligence and artificial intelligence. Then display some results of the models I used, and lastly, offer my final thoughts and recommendations moving forward. To begin, we must understand what it means for a meme to be considered hateful. Here is an example of a hateful meme. But why is this meme deemed to be hateful? If you just look at the image itself, there is nothing hateful about it. It's simply a skunk. However, the text in the image adds a completely different meaning to the meme. As you can imagine, it can be difficult to detect hate speech in memes because hate speech depends on the context of both the image and the text. Relying on just text or just images to determine whether or not a meme is hateful is insufficient, which is why the algorithm that is developed needs to be multimodal. Multimodal hate speech is simply the combination of images and text, or data modalities, that creates or infers a hateful expression. Hate speech has become a frequent and common occurrence throughout social media platforms today. Facebook AI defines hate speech as a direct or indirect attack on people based on characteristics including ethnicity, race, nationality, immigration status, religion, caste, sex, gender identity, sexual orientation, and disability or disease. Facebook defines attack as violent or dehumanizing, comparing people to non-human things, for example animals, statements of inferiority, and calls for exclusion or segregation. Mocking hate crime is also considered hate speech. Facebook's statement and policy on hate speech is as follows. We believe that people use their voice and connect more freely when they don't feel attacked on the basis of who they are. That's why we don't allow hate speech on Facebook. It creates an environment of intimidation and exclusion, and in some cases may promote offline violence. So, how can Facebook reduce the amount of hate speech on their platform to increase corporate social responsibility? And by identifying hate speech, how can Facebook reduce offline violence and promote an environment of inclusion? To answer these questions, I believe Facebook must have the following business goals in mind. One, to increase corporate social responsibility and profit margins, and two, work with their advertisers to endorse non-hateful speech. The data source for my analysis is from the Hateful Memes Challenge set hosted by Facebook and Driven Data. The dataset contains the memes themselves and string representations of the text and the image. To analyze the data, I will use the memes and the strings of text to predict whether a meme is classified as hateful or non-hateful. The outcomes of my analysis will be based on the accuracy and probabilities for each prediction. For my analysis, I will use a Colab Python notebook as my guide for executing the data processing steps. And in my analysis, I will use MMF, which is a natural processing language powered by PyTorch for multimodal vision and language research from Facebook AI Research. The Hateful Memes dataset consists of 3 files in one directory. The 3 files are meme ID, meme image file, and meme text file. The directory is called img and contains all of the meme images. I will match the meme images and meme text based on the variable meme ID. I will combine the meme ID, meme image, and meme text with a binary label where 1 means hateful and 2 means non-hateful. The probability scores will be based on memes that are hateful. After submitting a prediction, I will train an existing model in MMF on the Hateful Memes dataset to build and train my model on the Hateful Memes data. I will use the AUC ROC, or the area under the curve of the receiver operating characteristic, as my performance metric. AUC ROC measures how well a binary classifier discriminates between the classes as its decision threshold is varied. Therefore, I will submit probabilities for each prediction denoted with the float proba. I will also calculate the accuracy of my predictions, which are the ratio of correct predictions to the total number of predictions made. The accuracy of my predictions will be determined by both the binary labels and probabilities. So what is really going on behind the scenes of the Facebook AI model, and how exactly does it work? Well, to understand how the modeling for the hateful memes dataset is working, it is first important to understand the parameters and definition for what the model considers to be a hateful meme. The model is basing its classification on Facebook's definition of hate speech, which is a direct or indirect attack on people based on characteristics including ethnicity, race, nationality, immigration status, religion, caste, sex, gender identity, sexual orientation, and disability or disease. Mocking hate crime is also considered hate speech. Secondly, the model is constructed such that unimodal models, just images or text, struggle, and only multimodal models, the combination of images and text, can succeed. Upon doing further research on the Hateful Memes Challenge, I found that human accuracy is at 84.7% for identifying whether a meme is hateful or non-hateful. State-of-the-art methods perform poorly compared to humans at 64.73% accuracy, illustrating the difficulty for artificial intelligence to detect hate speech in memes and highlighting the challenge that this important problem poses to the social media community. The fact that even the best multimodal models are still very far away from human performance shows that there is much room for improvement. The reason machine learning algorithms struggle and cannot equate to human success for identifying hateful memes is because it is difficult for the algorithms to multitask and interpret the combination of words, images, like the way human intelligence can. The machines can detect unimodal cases, just text or just images, but decisions for multimodal content are more challenging to make and require real-life context and common sense that humans have. To increase the accuracy of Facebook AI's model for identifying hateful memes, the model uses benign confounders, which are a minimum replacement image or replacement text that flips the label for a given multimodal meme from hateful to non-hateful. For instance, in the "Look How Many People Love You" meme, one could replace the image of a crowd with an image of a desert, as shown here. If the image were replaced, it would change the meaning of the meme and deem it to be hateful. The benign confounders improve the accuracy of the model by detecting multimodal hate speech. The benign confounder construction phase also allows the model to spot memes that are only unimodally hateful. If it is not possible to find a replacement text that flips the label, the image itself is hateful. The same is true in the other direction. If no replacement image can flip the label, but is somewhat more complicated, and since it might be that it was simply not possible to find a suitable replacement image. Benign confounders contribute to advancing machine and deep learning methods for identifying multimodal hate speech in memes. After visualizing the dataset, I tested the pre-trained model in the Colab notebook. To test the model, I inserted an image, URL, and text. I used an image with a large crowd and entered the text, "Look how many people love you," in my model. My dependent variables in the model are the binary labels, one for hateful, and no, meaning the meme is not hateful. The pre-trained model shows that the meme is non-hateful with over 99% confidence. However, the same is true when I change the image to include a barren desert and leave the text as is. The model still concludes that the meme is non-hateful with the same level of confidence. Whereas human intelligence can clearly identify the difference between the two memes, this example shows that the pre-trained model could use further improvement and is behaving in a rather unimodal way. I also found it interesting that the model confidence for this meme is over 99% for both memes. So how could I improve the pre-trained model? The model I chose to use for prediction is a multimodal bitransformer, MMBT for short, that jointly fine-tunes unimodally pre-trained text and images. Though the MMBT model is not as accurate as some of the other models, the MMBT model is advantageous to use in that unimodally pre-trained models are simpler and easier to adapt to unimodal advances. For example, it is straightforward to replace the text or image encoders with better alternatives and directly fine-tune without requiring multimodal retraining. The model uses self-attention over multimodal content to perform classification. Utilizing the same transformer to use its attention modules and combining the embeddings of the different modalities leads to a simple but powerful model that obtains better results than only looking at the image or only at the text. Essentially, as shown here, the MMBT model combines the text-only self-supervised representations from natural language processing with the power of state-of-the-art convolutional neural network architectures from computer vision. The MMBT model is straightforward and intuitive, and importantly, is easy to implement even for existing self-supervised encoders. After selecting the MMBT model, I ran predictions and evaluation models on the validation set for the hateful memes data. The validation set had more non-hateful memes than hateful memes. The validation set contains 540 meme predictions. 470, 87% of the memes were predicted to be non-hateful, and 70, 13% of the memes were predicted to be hateful. Next, let's look at the test set. Whereas the validation contained 540 meme predictions, the test set contains 2,000 meme predictions. Interestingly, the prediction and evaluation models result in drastically different outcomes in the number of hateful memes for the test set. The test set detected more non-hateful memes in the prediction model than the evaluation model. In the prediction model on the test set, merely 2 of the 2,000 memes were assigned as hateful. However, in the evaluation model, 22% of the 2,000 memes were assigned as hateful. Another insight I found quite peculiar was that although only 2 of the 2,000 memes were hateful in the prediction model had a higher percentage of average prediction, 26% to 18%, than the evaluation model. Lastly, for both the test and validation sets, the prediction model had the best average probability score that the meme was hateful. The average probability that the meme was hateful in the validation set was predicted to be 39%, whereas it was 19% in the evaluation model. 39% is the highest prediction percentage I got from all of my models. However, 39% is significantly below the 64.73% set by state-of-the-art methods I had mentioned earlier in my presentation for identifying hateful memes. Some of the biggest lessons and takeaways I got from tackling this project were that learning a new language takes time and effort. Although I was able to manipulate the code in the Google Colab notebook, I ran into many errors and hurdles I had to interpret. Another thing I learned was that hateful memes are complex and difficult to identify. The most accurate way to identify memes as hateful or non-hateful relies on a variety of factors, including the definition of what a hateful meme is, which model is used, and if the model is unimodal or multimodal. Thirdly, I researched and found that state-of-the-art models are not as accurate for identifying hateful speech and memes as humans are. To train the best models, data scientists must use neural networks and multimodal content to string together text and images to identify hateful speech in internet memes. Do I think one day AI will surpass human intelligence for identifying hateful memes? Surely, and more than likely sometime soon. The issue of hateful speech on social media platforms has been a hypersensitive topic in our society today, and researchers are attempting to solve this problem by removing the speech. However, I believe it is encouraging to see that no matter how vast neural networks and intelligence can be, human intelligence still reigns over AI in regard to deciphering hate speech in internet memes. Please leave any questions, comments below in the comments section, and thanks for listening.